Hi, I'm Kassidy Rodriguez, and I'm here today because your professors have invited me to come give a speech about a very, very simple topic of science about how things have different types of densities. So, anyone has the ability to stack blocks or boxes on top of each other, but with a steady hand and a little understanding of chemistry, you are able to stack liquids. So, how does this happen? How are you able to stack liquids on top of each other? Seems pretty foreign for some people, for a lot of people. No, dumb. So what is density? We all know that something can float in water and some things can't. Like rocks, for example. You usually don't expect a rock to float on top of water. That would be a little bit strange. You wouldn't be able to skip rocks that easily. They would just putter and stay on top of the water, and there would be no point in counting how many skips you have. It's a little bit sad, so no competition there. But rocks sink, and air bubbles in water will always come up. And this is because the densities of the two objects, the two materials, three materials. But the density of a material does not depend on the weight. So things that weigh more than each other, you can have 20 cupcakes and they'll weigh more than one cupcake. But you can't have, but you could possibly have one rock that weighs more than another rock, but they are the same amount of rock there. So let's say you have a finite amount of something and the same amount of the other. So you have 50 milliliters of water, and then you have 50 milliliters of honey. Which would weigh more, and why? So some people like to have honey tea, or they put honey inside their tea, and what you notice is that the honey doesn't float on the top, it goes directly to the bottom. Then you mix it in, stir it in, do whatever you want with it. But the honey will always go to the bottom. And this is because honey is a lot more dense than water. So what there is usually water is erase. Let's see. Oh, okay, performing the experiment. Let's show you how I came up with this mixture, which is on the bottom is honey, corn syrup, maple syrup, milk, dish soap, water, vegetable oil, rubbing alcohol, and lamp oil. And on the top is a ping pong ball to show that air is a lot less dense than all these other than liquid. And so what we're going to make today is the same thing that I have in this right here. We're going to do it in this one. So honey, you have to put it on the very, very bottom at the very start. And this is because if it gets on the side, it can mess with the experiment and contaminate some of the other parts. Though it'll eventually come to the bottom, won't happen right now. So we'll throw a little bit of honey in there, make sure it doesn't hit the bottom, make sure it doesn't hit the sides, excuse me. Some corn syrup, some maple syrup, throw a little bit of milk in there, some dish soap, some vegetable oil. Oh, wait, excuse me, we'll put in some water first. Put in some vegetable oil, rubbing alcohol, and lamp oil. And some of these have been colored differently so they're easier to see. And so what you can see now is that these have all been separated out. Though they're not as defined as this has been setting out for quite some time before this experiment started, just to show you the definition of color. But with this, you can see that the layers in between them are very defined, and you can see the honey, and you can see the milk, you can see the water, and you can see the lamp oil. They're all very, very defined in this glass. But so how does this happen? With the density of water being lower than honey, honey sinks to the bottom. But so why is this? Honey is going to have more molecules packed into the same amount of space as water would have the same molecules packed into the same space. So what this means is that the more molecules you have in one area means how dense the liquid is. And this is why rocks this is why rocks sink. They sink because they have more stuff in one area than water does in the same amount of area. So what does this have to do with everyday life? The most important, I think, is that without ice, so ice floats on water. And this is because ice is less dense than water. So this is important because if we didn't have ice on top of water, we wouldn't be able to go ice skating. And this would be terrible because hockey wouldn't be that fun anymore. Cross-country skiing wouldn't be that fun anymore. Ice fishing wouldn't even be a thing. We all know from Minnesota, we all love ice fishing. So, but more importantly, if ice didn't float on water, it was not as dense, we wouldn't be able to have ecosystems in the water because when things froze, all the ice would fall on top of the fish, killing everything underneath it. And that's one of the most important things about density of different materials that you should take home with you today, is that without density of different things, things would die, ecosystems would fail. And I will leave this out for a little bit longer so you guys can see that the separation of these two are the very same. They may have a different quantity because I didn't measure everything, but you can see the distinct layers and they will be the same as the one in the beginning. Alright, thank you guys.